Hi guys, in our final example about the simple gas laws, question number 5. This is a medium question. It's not easy for people who haven't practiced enough. It's mainly related to the gas laws we studied, and specifically the ideal gas law and how to use it or incorporate it in order to find specific components. So in this question over here, we have carbon dioxide of volume 62.5 liters. The mass is given to be 59 grams, and the pressure is given, and it's 34.5 times 10 to the power 5 Pascal. So given also the R, which is a constant. Now in this question they gave us both R's, so 0.082 liter atmosphere per Kelvin mole, and the R 8.314 joules over mole Kelvin, or 8.314 Pascal multiplied by meter cubed over mole Kelvin. So the question is, what is the temperature in Celsius? So, as we probably know that we're going to have to use the ideal gas law. Remember that the difference between using general gas equation and ideal gas law is general gas equation is usually used when you have sort of an initial and a final condition. In this case, we only have one condition and we want to find the temperature at that specific condition. So let's go ahead and use the ideal gas equation, which goes by PV equals nRT. So we know the pressure, we know the volume, we have R, we have to decide which one to use, and R, deciding which one to use is based on the units that is given to you, and we're going to discuss this soon. And then you have the temperature. So we want to find the temperature, and we also don't have number of moles. So first things first, let's find the number of moles. So number of moles in this case, we're given the mass. So number of moles equals mass over molar mass equals 59 grams over the molar mass of carbon dioxide is 44 grams per mole. So if we cancel off the gram, we're left with moles, and 59 divided by 44 is going to be equal to 1.34 moles. So now we know the number of moles is 1.34 moles. Now we still have the temperature, which is what we need to find out. Now the second question we're going to ask ourselves is, which R should we use? So the R for 0.082 is in liter atmosphere over Kelvin mole. Let's see what we have. So liter is for volume, and atmosphere is for pressure. In this case, the volume is given to us in liters, but the pressure is given to us in pascals. So we can, if we want to use this value, we have to convert the pascals into atmosphere. In the other scenario over here, for R, is 8.314. In this scenario, we have Pascal meter cube, right? So we could switch up the liter into meter cube. Whatever is easier for you guys to do, of course. For this specific example, we're going to actually convert pascals into atmosphere. So let's go ahead and do that. So now we're going to see we have 34.15 times 10 to the power 5 Pascal. Now in order to convert to atmosphere, we need to find the relationship between Pascal and atmosphere. And the relationship goes by this. 1 atmosphere is equal to 101 times 10 to the power 5 Pascal. So when we multiply by this relation, we can cancel up the units, and we're going to be left with, over here, if you do the calculation, you should end up with 0.34 atmosphere. So now we have the pressure in atmosphere and the volume in liter, and the temperature we're going to have in Kelvin once we calculate, and we have the number of moles. So now, pretty much right now, it's straightforward. So if you switch up reorganize this formula here, you got T equals PV over NR. Do the calculations. So P was 0.34 atmosphere times the volume is 62.5 liter over number of moles turned out to be 1.34 times the R, we said we're going to use this R, 0.082 liter atmosphere over Kelvin mole. So let's cancel out the units over here. Liter cancels out with liter, atmosphere cancels out with atmosphere, mole cancels out with mole. So we're left with Kelvin, which should assure us that we are doing the right thing because Kelvin is the unit for temperature. So right now, if we do the calculation over here, we have 0.34 atmosphere, 0.34 atmosphere multiplied by 62.5 liters divided by 1.34 moles, and then you divide it by 0.082 liter atmosphere per Kelvin mole. You should end up with 193.4 Kelvin. So you should end up with 193.4 Kelvin. Now, this is not the end of the question. The question asks us what is the temperature in Celsius. So in order to find the temperature in Celsius, remember that when we convert from Celsius to Kelvin, we add 273. So when we convert from Kelvin to Celsius, we have to subtract 273. So if we do the subtraction, we're going to end up with negative 79 degrees Celsius. And this would be your final answer for this question. So again, in this question, we managed to use the proper units in the ideal gas law. And we made sure that all the units cancel each other in order to end up with the right unit that we need. And this should give you just a sort of overview of what you might face in an exam question.